Find the velocity vector for a wind that is blowing in a direction of south 30 degrees west at 10 miles per hour. So the velocity vector is basically asking for the vector components, right? So let's read this a little bit more carefully, right? So we know that this is a wind, okay, it's blowing at a direction of south 30 degrees west. Okay, the first thing we got to do is just determine what direction that actually is, right? So south 30 degrees west. Okay. So how do we determine that? Well, the first thing we do is we go south, which is obviously this direction, right? So from the origin, we're going to go south. And then the next two, right, the 30 degrees west means we're going to sweep at an angle of 30 degrees in the west direction. Okay, so south is this guy right here. And we're going to go 30 degrees in the west direction, which is here. So this angle here, right? This angle here is going to be 30 degrees. Okay, so south, and then we're going to go west 30 degrees. And the vector, right? The wind is 10 miles per hour. That's this guy, right? This length or the magnitude of this vector is going to be 10. So then what is this question asking? The question is asking us to find the components, right? We're going to find the horizontal component and the vertical component here. Okay, how are we going to do that? Well, we'll just use a little bit of trick. Okay, we know that this vector, right, we'll call it v, is going to equal the magnitude of v times cosine of theta plus, or I guess we should say, right, because that's the horizontal component, and then the magnitude of v times sine of theta, and I'm going to put that j there. Okay. So remember, the I and the j represent the corresponding components, right? So this is, and then to find these two guys, we just use a little bit of trig, right? Okay, so the magnitude times the cosine of theta, the magnitude times the sine of theta. Now you got to be a little bit careful here, right? The angle is not 30 degrees. What we need is this angle here, right? We need this angle right here. Okay. In this case, well, I know that this is 30 degrees, right? And from here to here is 270. So this angle here, theta, right? Theta should equal 240 degrees. Okay. And notice we already know the magnitude, right? So let's just go ahead. The velocity vector is going to be 10 times the cosine of 240 degrees, I. Remember, this is not the I, which is the square root of 1, right? This is the I, that is the horizontal component of the vector. And then plus 10 times the sine of 240 degrees, okay, and j. Okay. Well, we know what the cosine of 240 degrees is, though, right? That's negative 1/2. So we're going to get 10 times negative 1/2 I plus 10. And then the sine of 240 is negative rad 3 over 2 times j. So then our final answer here, the velocity vector would be negative 5I minus 5 rad 3j. And notice what these two numbers mean, right? That means we would go to the left 5 units, and we would go down negative 5 rad 3 units. So this is the final answer, right? Whenever it asks for a vector, it's always asking for its components. In this case, the horizontal component and the vertical component.